about that.
Yeah, it's late in the day and late in SLI, so perhaps I just missed the crucial thing. But so all this depends, of course, on the P matrix, and so who are the easy targets and how many moves are around, etc. So did you average over many random initializations?
Yeah, many.
So I might be right with the eigenvector strategy in monarchical societies, while in democratic societies it doesn't really communicate something like this.
So I didn't get that.
I mean, if I live under Stalin, then I have to convince Stalin that I'm done. If I live in the West, then I have to buy the media and, you know, come for the web, so I need to communicate much more. So I think different networks
Yes.
have a different dynamics.
Yeah, so what I did is I had 100 trials for scale-free networks, 100 trials for totally connected networks.
Okay.
And then for each of those, I generate a random P matrix that respects that network topology. And the difference is, in a sense, that between America and maybe Stalin, the more structure you have, the more maybe centralized structure you have, the more you get out of eigenvectors. So if you have a homogeneous society, forget about targeting influential people, because
there are more.
there are.
Okay, I think we should go on to the next talk. Thank you very much
Okay,
again.
thank you.
Next talk is by Jason. And I already introduced at the beginning.
Okay. Hey, when do you want me to stop? 20 minutes. Until 15, maybe 5 until 5 more. Okay. All right, thanks everyone. This is really exciting. When Roland and I taught this course together, we had no idea that it would be something at ESSLLI, and yeah, thanks for being here. I'm going to talk about all this stuff on here if we can, and we'll make it quick. Let's start with this. Altruism is a word for those who can't endure their desires. Maybe it's not the desires, but it's the consequences of the desires that we should be worried about. The question I want to ask really is, what sustains this conventionalization process? In all these multi-agent system models, we often assume that there is a guaranteed link between the agents. So when I asked the question yesterday, what if there's not? What if we opt out? What if there's an opt-out condition because maybe it's just not worth it to have that link? So I want to ask, what gets that link going so that then we can get the conventionalization process going and have some kind of communication? To do that, I want to distinguish cooperation from coordination, and I also want to look at trust games as a way of understanding that. So if you look here, this is one instance of the prisoner's dilemma. You can see the nice payoffs for cooperation here and the Nash equilibrium here that rational agents would end up in. Why is that? The action of defection, D, dominates that of cooperation. We can also look at a version of this similar called the stag hunt, where in fact this action here is also an equilibrium, as is the one for mutual defection. You can think of this like so, and I think of this working on politeness. Politeness takes effort on the part of both people. Maybe it's just not worth it in this single instance, right? Maybe I should not follow that strategy. But if there's a norm promoting it, it's going to change the incentives to where the person not being polite is the one punished. The person not following even a Gricean communication standard is the one going to be punished. I hope that is clear. With a norm in place, then we can have the conventionalization process and arriving at some kind of mutually beneficial social contract. Okay, cool. Here are some variants of the prisoner's dilemma, and I want to highlight this more general version of the idea of both cooperating. It means we pay a cost to do so, and we arrive at a benefit from the other's cooperation. Is that all good? Okay. Now there is an asymmetric version of this called the trust game. So if you like thinking with concrete numbers, You can think that Agent X has an option to ask or not. Agent Y has an option to help or not. And we can go through the game a little bit. Think about it. From this state, Agent Y in the second payoff would prefer to not help. And if Agent X knows this, he would then prefer to not ask. Now, I've made this reward here mutually the same. That's up for a little debate. And the idea is that this benefit of not helping is greater. So keep that in mind, that B is always going to be greater. The B is bigger. Think about it like Michelle's biceps, bigger. Okay? The cost here is also going to be negative. Oh, this says time for a game. Maybe we should play one right now. I'm going to give you 5 seconds to look at your neighbor and identify which one of you is X and which one of you is Y. Can we all do that real quick? Let's go ahead. 5. Go ahead, look around. Look around. Look around at your neighbor. Okay. X. 4, 3, 2, 1. X. Raise your hand. Raise your hand, X. X. Hold your cell phone up. Go ahead, take out your phone. Take out your phone. You got a phone. Got a phone. Go ahead. About. Okay. X, that's your phone. That's your phone. Okay. Now, X, you are going to trust Y with your phone for the next 15 minutes. Right? Go ahead. As an act of good faith, I'm going to do this with someone I don't know. So, I don't know you. But do you feel that? Do you feel that right there? Do you feel that right there? Like, you're in a minus spot right now. Okay? And you say, oh wait, the phone is the way through which I negotiate my social life. It's my access point to everyone in my social network. Well, we haven't had phones for a long time, but politeness theorists would say we have the same mechanism in language every day. It's called face. It's called face, the way we negotiate our social identity. Okay? Now, let's move forward. Person X, how are you feeling about this? Right? We could also take the game and symmetrize it. So we could take this game and put Y in the position of asking and X in the position of helping. So now person Y, you are going to take your phone. Go ahead and take your phone out, person Y. And you are going to give it to person X. And it maybe as a show of good faith. I mean, with someone else, I don't know. Well, here you go. Okay?
Wait, I am X.
Oh, yeah.
You get one.
All right, and now, wait, this still feels like a dilemma. And we could take these payoffs and imagine both players playing both roles and add up their respective payoffs in either game. Now, this still feels like a dilemma. And if you saw, it looks like the prisoner's dilemma is hiding out right here. Right, hiding out here. We're going to go a little more in depth into that. Okay? What is the equilibrium for this game? For this repeated, or for this single instance trust game, symmetrize. We're going to find out in just a minute. Now, to get there, this is some fancy stuff that I call strategic restriction. It just means throwing a strategy out. It could be because there's a norm against it. It could be because of unawareness, as Mikhail has looked at a lot in some of his papers. Maybe we're not aware of all the strategies in a game. We can throw them out. We can also throw them out because we see they're not better than another. So you can have variations of trust. You can see the various payoffs that come about here. This is not interesting because if we throw out asking, nothing happens. This can be a prisoner's dilemma with appropriate payoffs. These are if we know the other person will always ask. We can then have variations of trustworthiness. Notice that if we throw out the action of helping, we do arrive at this interesting prisoner's dilemma. And then if we know the other person will always help, this is a pretty easy game to see where it will land. Okay, it will land in that best outcome. So I've named these various items: friendly, altruistic, insistent, and reclusive, just to give you some personality types that might resonate. And we're spelling that out right now. What we want to do here is we're going to account for the various types of strategies that could be in a game, especially as I think about eliminating them or seeing which ones dominate the gameplay in the very end. So we could eliminate friendly players, and at the first glance we would see we would get a Nash equilibrium at not asking and not helping. We could also eliminate altruistic players. That same Nash equilibrium of not asking and not helping arises. If we eliminate insistent players, those are the jerks. They ask and they don't help. We can get two different Nash equilibria. Naturally, this is the one we would like to select. And if we eliminate reclusive players, we get this equilibrium of being insistent, of asking and not helping, but we also get some asymmetric equilibria as well, which I'm not going to talk about today. Now let's go back to our original game. I'm going to claim this equilibrium of not asking and not helping, the one we saw in the asymmetric version, is also going to be the same. What you can see here is that the altruistic strategy is the one we throw out. It's weakly dominated. Throw him out. Next, we would see that the strategy of asking and helping, the friendly strategy, would also be weakly dominated. We can throw that one out, and we land at this version of the prisoner's dilemma that we mentioned earlier. Now look at this right here for a second and think about what we just did, right? It's not a norm. There's no need to normalize asking for help, trusting. But there is a norm in most societies about being trustworthy, right? Notice what survives in the iterated elimination, untrustworthiness. This is why we need the norm, because it's such a tempting desire. Does that really make sense to you? Okay. Now, once we're in this game, this is the prisoner's dilemma, not asking, not helping is what was survived. Now, wait. This would mean that language itself, communication itself, social networks itself will not even exist if this were happening one time. So we need to find conditions that promote some better outcomes. Right? What we're really trying to do is take symmetric games like the prisoner's dilemma and turn them into games like the stag hunt. Now, all these inequalities just mean I want this mutual cooperative outcome to be greater. Now, the Folk theorem is a theorem from repeated games, so what we're going to do is we're going to repeat this instance. What the Folk theorem says are really two things. One, the whole set of feasible payoffs in the repeated game, the ones we can land at, are going to be, I can use the word convex hull, or just in between the extremes of the original game's payoffs. Okay, that's one thing. Two, we could land at equilibria, but all the equilibria we will land at in repeated games will be, or have to be, better than this original, it's really the min-max profile, but the worst case scenario. Okay. There are a few different cases we can look at. One is when, notice, remember that C? That C was that cost, or you think C for cell phone? All right. It was that cost. If the cost is low, we have a lot of different equilibria. Taking them out, notice this insistent one still stays. If the cost is in between the reward and that benefit, we still get a lot of these equilibria preserved. And if the cost is high, we get less and less. And notice how they start pushing towards the one we want. Okay? As you get the higher domestic costs, that's what's going on there. Right? If you've got this repeated game, you have all kinds of strategies. We can't cover all of them, okay, in our finite time, but I want to talk about just a few of going from each state to the next based on what the previous play was. Okay, we just mentioned this feasibility condition, but maybe it looks better in a picture. So in the repeated prisoner's dilemma, this is the set of feasible outcomes, okay, in the repeated game. As we go through our different versions here, this kite-like shape would be the set of feasible outcomes in the repeated symmetric trust game. Notice this is for low cost. So I say for low cost, notice what can survive. What can survive are these even asymmetric points here. Go forward. As we go forward, as cost becomes moderate, then this is still the feasible region of payoffs that could happen, but which ones will be equilibria? Go back again, remember they have to be better than 0, 0. So even though these could happen, strategies that lead to these payoffs will not be equilibrium. Okay, the equilibrium will be in this section here. Notice, just like we said again, it seems like as cost is going up, the set of feasible outcomes that could be equilibria are compressing. Once again, we only get these outcomes in the first quadrant. If that picture helps a little more. Wait, you're thinking, what are these outcomes again? Just so we're clear, the x-axis is player X's payoff, and the y-axis is player Y's payoff, if that wasn't clear before. Okay, so that should be high. All right, we looked at this case a second ago, and this one is case 2, moderate cost, and case 3, high cost. Now, while you look at this big fancy formula, I'm going to get some water, and what we're doing here is think about, we've got an infinitely repeated game. What we don't want is infinite payoffs. How do you compare 2 infinitely many times to 3 infinitely many times? We need to discount each future interaction. So what's happening here is I'm placing a discount value on how much do I value tomorrow? How much do I value my interaction with you tomorrow? That discount value is between 0 and 1. The nice thing about the math that works out is when you add them all up, you get this expression which you're going to see pop up a lot. What's happening here, we're summing up the discount value for that game repeated that many times to the t power. Here's a utility function, some kind of value for agent I, and agent I is playing some action against agent J. Now this is a little unfortunate notation, but this is at time index t. This is not an exponent here. Okay, so only this is an exponent. This is just a second marker of what time index we're at. Okay. What we really want to do then to satisfy the conditions of the Folk theorem is we want to find equilibria in the repeated game that will satisfy these feasibility conditions and to give us Nash equilibria. All right. Here's a cool one. I call it friendly imitator. All right. So you ever been to a party? I went to the essay party, right? And you start off with some strategy, but then you say, well, let me imitate those around me. This should remind you of tit for tat in the repeated personage dilemma. What friendly imitator does is starts out with a friendly strategy, and then whatever it sees against the other strategies, it will repeat itself. Okay there? Okay. Well, this is what you would do to construct a payoff matrix. You would just look at the respective payoffs of this strategy against each of the other ones. And in this case, I'm assuming that we're all playing naive strategies. This is just for the slides if you want to look at it on the web. But what we want to arrive at is a payoff matrix where we need to compare this outcome against this outcome right here. In other words, how does a friendly imitator play against himself versus how does this insistent player play against the friendly imitator, and see if we can compare them. Remember that this B is greater than R, so if you covered up that part right now, R plus B is greater than 2R, so I need to find the appropriate discount value that will make this work. Now, once again, discount value. This is another way of saying a measure of patience. How patient do I need to be with you to make this friendly strategy pull through? Perhaps think about the bus driver. You might not ever see the bus driver again. Maybe you don't need to be too patient with him to make your interactions work out well in the future. Does that make sense, everybody? Okay, so I want to find out that patience value. So we can do some fun inequality work, and we get a nice little result to compare those. I'm going to make a table of those in just a second so we can compare all the different strategies. We can also have a strategy that I like to call friendly punisher. So this is related to the grim trigger strategy. Okay. Maybe a t-shirt around. Okay. You're thinking of someone that starts out friendly, but if there's any other strategy that's not friendly, he punishes them by playing the worst possible action. This one right here, not asking, not helping. So he shuts down any future interaction. You can also go through that same process and find the discount value that produces an equilibrium. I'm going to hold off on this for just a second because we should see something neat. if you compare the imitation dynamic versus the punishment dynamic, what you see here up top, this is the difference between the payoffs for not helping and helping. It's benefit minus the reward. Down below, we see this R plus C. Notice what's happening here. I have B minus R in both cases, but down below I have this B right here. Right? What this means is that we're any positive benefit, and B is always greater, so we're going to assume that it's positive. As we look at the punishment versus imitation dynamics, what we see is that if we have imitating strategies, the players need to be more patient with each other. If we're only doing what others do around us, we need to be a little more patient with each other. But if we have the perspective that someone might threaten us or punish us with some drastic action, we don't need to be too patient with them to sustain that friendly equilibrium. If that makes sense. Meyerson called that idea a credible threat. That's one. You can kind of think of this like this armed society as a polite society. If you have this credible threat of punishment, then you're going to sustain the friendly equilibrium. I want to also notice something else too that Robert Van Roy and I talked about a lot. Look at this cost here. Notice that the cost is on the bottom in both cases. So as we get higher cost to the message, that face cost that I have to admit when I make a request, as that goes up, then guess what? Right? We don't need to be so patient. We get like a higher probability of that friendly imitation or friendly punishment being sustained. Okay. Insistent strategies can also be equilibria in the repeated game, and maybe I'm going to punch through this just a little bit, but notice this happens when we have a lower cost of message. If messages are cheap to send, if there's a low face cost or a low cost trust to send, then I might speak more insistently, and I might not even be worried too much about helping someone out. So you can also see a strategy that would begin with insistence, and it would follow this imitation dynamic. It yields an equilibrium, and I'm going to show another one that would start with insistence, and it would also end with the same equilibrium. But notice this one would punish instead of imitate, and it would just go straight to the punishing action. If you can't see that right there. If I look at what's going on here in a table, think about the friendly strategies. Notice we just described those, but the equilibria we get sustained by this patience value are reversed in a way for the insistence. In other words, as messages become more costly, I might want to be more insistent. Okay? As messages become more costly, this insistence. I'm sorry, pardon me. I might want to be less insistent and follow the friendly strategies. Okay? I told you a minute ago we would get to here, right? We would get to this win-win scenario. Is that right? Player X, where are you at? Player X, where are you at? Several. We should have 5 or 6 around the room, or 10. That's several player X's. Okay. Player Y, raise your hand. All right. Player Y, you are now going to give that phone back to player X. Go ahead. All right. And player X, you are now going to give that phone back to player Y. All right.
Next one.
No, yeah, so each of you should have you all have your original phone? You all have that? Okay. Don't you feel better now than you did a little while ago? Do you feel like we're right here in this win-win scenario?
Does this apply to wallets too?
What's that?
Does this apply to wallets?
It will in a bit. I trust you. Okay. So I told you we'd get here, and these are just some of the mechanisms that will get us to these win-win scenarios. They are not all of them, and I really want to be cognizant of that. And notice that we played against some of these naive strategies. So what we really saw is that we're getting something that promotes a norm. Right? Under these certain strategic conditions, under this knowledge of repeated interaction, under certain discounts, we can find the paths that will lead us to this cooperative outcome being a norm among players that they'll both follow, right? Once we have that norm in place, as we said earlier, we can transform the cooperative dilemmas into problems of coordination. This is when we can have meaningful signaling. This is when we can arrive at conventions like implicature, whether it's a politeness one or a Gricean style thing. So if we looked at, you know, the different payoffs that would get us there, we need to think about how do we arrive at an evolutionarily stable strategy, one that plays well against itself, but also plays better against itself than these insistent strategies play against themselves. What this happens is when this benefit minus the cost is less than this R plus R, and this is essentially what happens when this payoff for both players is less than this payoff for both players right here. So doing that, right, allows these conventions to emerge. So what we've got here really is an evolutionarily stable strategy. And for these values, locally, licenses implicature. Now, you knew what I was going to say next, right? This tells me that this desired state is ESSLLI. Okay, but you know that anyways, right? If I were going to wrap up, once again, remember these punishment dynamics sustained this cooperation better, and we saw that the insistent strategies and the friendly strategies could be both Nash equilibria and evolutionarily stable states. It was interesting to see that under low cost, the insistent strategies could survive, and I think that's good. In fact, that we want to account for when they're featured in there. I didn't talk too much about indefinite repetition, but we can discuss that. And otherwise, I'll just say, the game's over. Thank you very much.
Okay, we have a couple of minutes for questions.